In this lesson, we will talk about how to multiply radicals that do not have the same index or that have different indices. So when we have radicals with different indices, we know that we can't just work with them the way that we have been because that value is the same. Now on the first one's going to be a little bit easier because if you'll notice, the radicand is the same, and so that will make it a little easier for us. I would just simply rewrite the fourth root of 3 into 3 to the 1/4. Remember, when we write them as fractions, the numerator is the exponent and the denominator is the index. So I would take 3 to the 1/4 times 3 to the 1/5. Now we know when we're working with exponents that when we have the same base, we can simply add those exponents together. And we know, working with fractions, that you would have to have a common denominator. So I would look at 4 and 5 and find the least common denominator, which is 20, and I would multiply by 5 here to make that 5/20ths, and I would multiply by 4 here to make that 4/20ths. And now I have two values that have the same base of 3, and they have fractions in the radical, and they have fractions in the exponents that I could add together. So this is 3 to the 5 plus 4, which is 9/20ths, which I could leave like that. Depending on how they want their final answer, I could also write this as the 20th root of 3 to the 9th, etc. Or I could go ahead and multiply out 3 to the 9th, and that would give me the 20th root of 19,683. Any of those would be correct representations. All correct. Now the second one is a little bit harder because, as you can see on my first example, my radicand was the same, which meant that I could use that power dealing with exponents where I could just add the exponents together. This one is not going to work that way because my radicands are not the same. So now I have a different index and a different radicand, which makes it more complicated. I'm still going to start my question the same way, so I'm going to call this 2 to the 1/3, and this is going to be 3 to the 1/2. And just as I did on the last question, I want a common denominator, so I'm going to turn this into 2/6, and this was a half, so now I'm going to make that 3/6. And now what I'm going to do is a little bit different than what I did in the last question. I'm going to rewrite this as 2 squared 6th root. So the 6th root of 2 squared, and I'm multiplying that by the 6th root of 3 cubed. Now look what we can do. So now we have the 6th root and the 6th root, and I've got some values on the inside. So 2 squared we know is 4, so the 6th root of 4, and 3 cubed is 27, so the 6th root of 27. I can multiply 4 times 27 to get 108, and so my answer is the 6th root of 108. And I, of course, would take some time to make sure that there are no perfect sixths that go into that. 2 to the 6th is 64, and 64 does not go into that evenly, so really nothing else is going to. So that's my answer. Try these two on your own and then press play to see how you did. For the first, I have x to the 1/2 times x to the 1/3. I need to make those denominators the same, and so I will call this times 3, so 3/6, and times 2, so 2/6. Now I can combine together the 3/6 and the 2/6 since my base is the same, and that would give me x to the 5/6. Again, I can leave my answer just like that, or I could rewrite it as the 6th root of x to the 5th. For my second, I have 2a squared all to the 1/4, and I have, oops, not 3, I have a squared b all to the 1/3. So let's work to make those denominators the same. Let's turn those into 12, so times 3 times 3 times 4 times 4. And now I'm going to rewrite that. Now remember, when I'm cubing, everything inside gets cubed. So when I rewrite this, this is the 12th root, but it's 2 cubed, and it's a squared cubed. My second one, a squared b, again is now to the 4th power, so it's the 12th root, but it's a squared to the 4th power and b to the 4th power. So it's important to do that. Now it's not important for me to write this step out, but I certainly can to make sure I'm keeping myself organized. So this is the 12th root of 2 to the 3rd, which is 8, and then a to the 6th. And then this is a to the 8th, so the 12th root of a to the 8th, b to the 4th. I'm going to combine all of this together. So that gives me the 12th root, and I have 8 times 1, which is 8. I have a to the 6th and a to the 8th, which is a to the 14th. And I have b to the 4th. And of course, as with any question, I would try to reduce anything that I can. So I see that there are 14 a's and my index is 12, so I'm going to bring one a to the outside, which is going to leave me with 2 a's on the inside. So that would be my final answer.